Hello everyone, welcome to all. In this video lecture, we are going to discuss about property diagram for phase change process for a few substances. First of all, we should know how the phase change process will take place. Let's see in detail. Let us consider a cylinder. It fitted with a frictionless piston. It can be loaded to any desired pressure. The cylinder contains 1 kilogram of ice at minus 10 degrees Celsius at the pressure of 1 atmospheric pressure. The stages of heat addition, it can be explained in different processes. You take it the phase change process of water in y-axis as temperature and x-axis as heat addition Q. Initially, the ice is kept at minus 10 degrees Celsius at point A. Now, we are adding some heat energy towards this ice. Its temperature will be increases from minus 10 degrees Celsius up to 0 degrees Celsius. At this stage, the ice remains a solid state only. So, from minus 10 degrees Celsius to 0 degrees Celsius, it remains in a solid state, that is from point A to B. When temperature rises from 0 degrees Celsius to 0.01 degrees Celsius, it starts to change its phase from solid phase to liquid phase. That is, when any amount of heat energy is added to ice, it gets warmer. Therefore, it is called as warming of ice. So, its temperature will be rises. That is described by the line AB. Now, the next process B to C. The ice starts to melt at 0 degrees Celsius and a two-phase mixture is formed, that is ice and water. Ice is the solid phase and water is the liquid phase. The temperature of this two-phase mixture of ice and water does not changes when heat addition because the phase is transformed from solid phase to liquid phase. At that condition, the temperature remains constant, but there is a slight decrease in volume because the liquid water at 0 degrees Celsius is heavier than the ice. At the point C, all the ice melts to water without change in pressure, that is 1 atmospheric pressure, and change in temperature 0 degrees Celsius. So, during the phase change process, the temperature remains constant. This phase transformation from solid to liquid, that is ice to water, is called as melting of ice or fusion of ice. So, the amount of heat required to convert the phase from solid state to liquid state, that is ice to water, that heat is called as heat of fusion. Okay. The next process C to D. When heat is added to the liquid water, now at the point C, the 100% ice is converted into water. When you supply some heat energy towards this liquid water, the following important facts are to be observed. That is, the temperature of the water is increased from 0.01 degrees Celsius to 100 degrees Celsius because at 1 atmospheric pressure, the boiling point temperature is 100 degrees Celsius. So, the temperature of the water can be increased from 0 degrees Celsius to 100 degrees Celsius. Whenever it reaches its 100 degrees Celsius, at the point D, it can start to change from liquid phase into vapor phase. So, what is the process of C to D? At C, the temperature of water is 0.01 degrees Celsius. At point D, its temperature of water is 100 degrees Celsius. So, only the temperature of the water is increases. Therefore, the process is called as heating process because temperature is raised from 0.01 degrees Celsius to 100 degrees Celsius. So, it is called as heating of water. The amount of heat required to increase the temperature, that is change the temperature, that is heat is called as sensible heat. Temperature மட்டும் நம்ம சேஞ்ச் பண்றதுக்கு அது இன்க்ரீஸும் பண்ணலாம் இல்ல டிக்ரீஸும் பண்றதுக்கு எவ்வளவு ஹீட் சப்ளை பண்ணிருக்கோமோ that heat is called as sensible heat. The next process D to E. At point D, 100% water is present here. After that reaches its 100 degrees Celsius temperature, when you supply excess amount of heat energy, it does not increases its temperature from 100 degrees Celsius to 101 degrees Celsius. That is, the 100 degrees Celsius is the saturation temperature, at which temperature the 100% liquid starts to convert it into vapor. So, after water reaches its saturation temperature, that is 100 degrees Celsius at 1 atmospheric pressure, any addition of heat will cause some liquid to vaporize at the same temperature. This is again a phase change process from saturation water to saturated vapor. During this phase change process, there exists a two-phase mixture, that is liquid to vapor. Water and vapor, that is called as water to steam phase change process. During this phase change process also, the temperature remains constant. You can see at point D, the temperature of the water is 100 degrees Celsius. At point E, the temperature of the water is 100, the temperature of the vapor is 100 degrees Celsius. The process of phase change takes place at constant temperature and constant pressure. At the state E, all the water has been vaporized, and the state of steam is called as dry and saturation steam. Because at point B, you can guess 100% of ice, at point C, 100% of water. Now, at point D, 100% of water, at point E, 100% of vapor. So, from A to B, heating of ice, from C to D, heating of water. But B to C, phase change process, temperature remains constant. D to E, phase change process, that is water converts into vapor. This is also a phase change process. Temperature remains constant. So, at the state E, all the water has been vaporized, and the state of the steam is water vapor is called as dry and saturated steam. The phase change from liquid to vapor is called as vaporization. The next process, at point E, 100% of water vapor is available. Once the steam becomes dry and saturated, it becomes as an ideal gases. And the steam is again heated. So its temperature will rises. Therefore, the steam is called as superheated steam. The process is called as superheating process, that is E to F. We know saturation pressure and saturation temperature, that is, what is the meaning of saturation pressure? At a particular pressure, the phase change process will take place, that is, the temperature at which the boiling and condensation of the fluid takes place, that is known as saturation temperature. So at which pressure the phase change process takes place, that pressure is called as saturation pressure. In the temperature la phase change agudho, saturation temperature. In the pressure la phase change process nadakudho, that pressure is called as saturation pressure. Okay. Now, the phase change process property diagrams. The first diagram, TV diagram, for the heating process of water at constant pressure. So the property diagrams is very useful for the study of variation of the thermodynamic properties during the phase change process. That is, one phase to another phases. So first of all, we have to discuss about TV diagram. That is temperature volume diagram. Okay. The phase change process of water at 1 atmospheric pressure. The TV diagram is very similar to that of from the state C to F. That is, it changes from water to vapor. In the previous diagram, we already discussed about the phase change process from ice to liquid, liquid to vapor, vapor to superheated vapor. Here only they consider the heating process of water only, liquid to vapor only. So it is similar to that of the previous process diagram. So we repeat the process of phase transformation from liquid water to vapor at different pressures. Okay. This is the first diagram for TV diagram. We have repeat the process of phase transformation from liquid water to vapor at different pressures by adding different weights on the top of the piston. At new pressures, the path followed by liquid to vapor phase change are very similar to the path 1 atmospheric pressure. As the pressure increases, the saturation temperature for boiling and condensation also increases. As pressure increases, the specific volume of liquid increases slightly, while the specific volume for saturation vapor decreases. So, the saturation line on the TV diagram will continue to get shorter. As the pressure increases, the temperature for melting and freezing is slightly decreased. All the saturation liquid states are connected by a solid line. That line is called as saturated liquid line. All the saturation vapors are connected by a line, that is saturation vapor line. the saturation liquid line and saturation vapor line meet at the critical point. It forms a dome-shaped structure. So, at a certain pressure, the mixture region will be represented by only by one point. You can see the lowest pressure as 0.01 megapascal. At that state, the process of phase change from liquid to vapor is like this profile. You can see. And when it increases the pressure, so its amount of heat required to change the phase from one phase to phase is very low, shorter region. And they increase the pressure, the heat of fusion or the heat of vaporization is region is very low. At a particular pressure, it suddenly changes into vapor. That point is called as critical point. So, at a certain pressure, the mixture region will be represented by only one point. This point is called as critical point. It is defined as the point at which the saturated liquid and saturated vapor states are identical. So, at this critical point, the properties of the substance are called as critical properties. At that critical point, what is the temperature? The temperature is called as critical temperature. The temperature at which the critical point is critical temperature. The pressure at which the critical point is critical pressure. The volume at the critical point is critical specific volume. Okay. So, some critical values are given for the water and air. For water, the critical pressure is 22.09 megapascal. Critical temperature is 647.298 Kelvin. And critical volume 0.330155 meter cube per kilogram. For air, the critical pressure is 3.77 megapascal. Temperature is 405.65 Kelvin and volume is 0.083 meter cube per kilogram. What is the meaning? Example, if you take the critical temperature of the water or critical pressure of the water 22.09 megapascal, at this point, at this pressure, whenever the fluid reaches its pressure or when the fluid is kept at this pressure, it reaches the temperature 647.298 Kelvin. It suddenly changes into liquid into vapor. So that is the critical point. It has the single point for phase transformation, but you can see the low pressure value. This is the high region of the heat transformation for phase change process, and this is the low. And compared with the previous pressure, it is very low, but finally becomes a point. That is, at a point, it suddenly changes into liquid into vapor. This is the PV diagram. If we connect all the points representing saturated liquid, we will obtain a saturation liquid line. If we connect all the points representing saturated vapor, we will obtain the saturated vapor line. So, this is the phase change process. Horizontal line represents the temperature remains constant. So, this is the heating process, sensible heating. This is the superheating of steam. So, at this stage, left side portion at point is 100% liquid and the rightward portion is 100% vapor. So, this is the saturation point, at which point the phase change process will take place from liquid to vapor. So, this is the saturated liquid point. If you connect all the saturated liquid points, you can get a curve that is called as saturation liquid line. If you connect all the saturation vapor points towards on the right hand side, you can get the saturation vapor line. So, the intersection of these two lines is called as critical point. If you can see, if all the saturation liquid points are connected by a line, and if you connect all the saturation vapor by a line, it gets a two lines. So this is saturation liquid line and this is saturation vapor line, and these two lines meet at a single point. That point is called as critical point. Okay, so this is next one. This is the TV diagram of a pure substances. This is the process. The left line is called as saturation liquid line and the rightward curve is called as saturation vapor line. If you connect all the points representing the saturation liquid, then you can get the line of saturation liquid line. Similarly, for saturation vapor line, at lower pressure, it has the maximum region of the latent heat of vaporization. That is a mixture of liquid and vapor, because the liquid is converting into vapor. So this is the mixture of liquid and vapor. And at a high pressure, it has the minimum length value. You can see this length of the line as minimum. It represents the latent heat of vaporization is very low. At a critical point, it suddenly changes into vapor. Okay. So all the compressed liquid states are located to the left of the saturation liquid line. That is called as the compressed liquid region. இந்த சேச்சுரேஷன் லிக்யூட் லைனுக்கு லெஃப்ட் சைடில் இருக்கக்கூடிய எல்லா ரீஜனுமே என்ன சொல்கிறோம் அப்படின்னா கம்ப்ரஸ்டு லிக்யூட் ரீஜன் சொல்லுவாங்க. All the superheated states or vapor states are located to the right of the saturated vapor line. That is called the superheated vapor region. In the superheated saturation vapor line இருக்கு இல்லையா, அந்த vapor line ரைட் சைடு இருக்கக்கூடிய region ஃபுல்லாகவே considered as the superheated vapor region. In these two regions, the substances exist in a single phase, only a liquid or a vapor. இந்த ரெண்டு ரீஜன்லையும் compressed liquid region or subcooled liquid region and superheated vapor region, இந்த ரெண்டு ரீஜன்லையுமே வந்து the substance will be single phases. In compressed liquid region, it occurs as a liquid phase, and in superheated vapor region, it looks like a vapor phase only. It occurs in only vapor phases. It does not involving the phase change processes. It does not involving the more than one phases. So during the phase change process only, it is a mixture of the two phases. Okay. So all the states that involve both the phases in equilibrium are located under the dome. That is called a saturated liquid vapor mixture line or saturated liquid vapor mixture region, and this is also known as wet region. You can get this dome-shaped structure if you connect all the saturation liquid line, and if you connect all the saturation vapor line, you can get a dumbbell-shaped curve. The inside the curve region, the region is called as saturation liquid vapor region because the liquid is converting into vapor, mixture of the water and vapor. So it is called as wet region. And this is the analysis of the critical point. And at that critical point, the liquid is suddenly converted into vapor. At before the critical pressure, that is, if the pressure is less than the critical pressure, the phase change process will take place. And above critical pressure, what happening? At supercritical pressure, that is above the critical pressure, there is no distinct phase change process. Boiling process நடக்க வாய்ப்பு கிடையாது. Next diagram, PV diagram. So the general shape of the PV diagram of the pure substance is very much similar to that of the TV diagram. Only the temperature range will be constant. But in case of TV diagram, pressure remains constant. In PV diagram, temperature remains constant. This is the process diagram. You can see this temperature profile. In the previous diagram, TV diagram, you can see this is the phase change process. The dotted line represents the phase change process. But here, PV diagram, the dotted line represents the constant temperature line. Same concept, but temperature remains here constant also. In the TV diagram, pressure remains constant. In PV diagram, temperature remains constant. For example, if you take a piston cylinder device, it contains the water. It has to be maintained at temperature 150 degrees Celsius and pressure 1 megapascal. So at the high pressure, the water is in this behaved as a compressed liquid. Now you want to remove the weight on the top of the piston one by one. So what happening? The pressure will be lowered. If you remove one single piece of weight, so it will be some losses its pressure. This it will released. So its specific volume will be slightly increases. So its pressure will be decreases. So when the pressure reaches its saturation pressure value, the water starts to boil. During the vaporization process, that is liquid to vapor phase change process, both the temperature and pressure remains constant, but the specific volume will be increased. Okay. So if we consider the pressure cylinder device, but with some weights above the piston, if we remove the weight one by one, decrease the pressure, and we allow the heat transfer to obtain an isothermal process, we will obtain one of the curves of the PV diagram. Next one, PT diagram. So the PT diagram is then pure substances generally called as phase diagram because it having the three phase diagram: solid phase, liquid phase, and vapor phase. It can show the three phases simultaneously. It has some features of the following. First one, each single phases, whether it may be solid or liquid or vapor, it can be separated by a saturation line. So the sublimation line separates the solid and vapor region. You can see this diagram. The sublimation line separates the solid and vapor region, and the vaporization line separates the liquid and vapor. And the fusion line, that is melting, the dotted line represents the fusion. This is the melting process, this is the fusion. And the fusion line separates the solid and liquid region. So the sublimation, fusion and vaporization line, it's meet at a single point. That point is called as triple point. So what is the meaning of triple point? The triple point can be defined as the locus where all the three phases of a substance are coexist. அந்த ட்ரிபிள் பாயிண்ட் வந்து எல்லா ஃபேஸஸுமே எக்ஸிஸ்ட் ஆகும். சாலிடாகவும் எக்ஸிஸ்ட் ஆகும், வேப்பராகவும் எக்ஸிஸ்ட் ஆகும், லிக்விடாகவும் எக்ஸிஸ்ட் ஆகும். So that is the concept of triple point. So at the triple point for water, the triple point temperature is 0.01 degrees Celsius and the pressure is 0.677 kilopascal. It's very important. So this diagram is also called as phase diagram because all the phases are present here. All three phases, solid, liquid and vapor phases are present here. So each phases are separated by a saturation curve, that is sublimation curve, vaporization curve, melting curve, fusion curve. Okay, so the substances expand or contract on freezing differs only on the melting line on the diagram. Thank you for you. If you have any doubt, please ask me. Thank you.